Good evening and welcome to day 3 of celebrating National Astronomy Week 2020 Mars Encounter. Thank you so much for joining us this evening. As you may have noticed in our intro video made by John Fox of Wheeldon Astronomers, the NAW is composed of several astronomy organizations around the UK, and you can find out more about us at astronomyweek.org.uk. Hello, my name is Lucinda Offer, and I am honored to be the chair of National Astronomy Week Mars Encounter. Tonight, my co-host is none other than Dr. Sandra Voss. Sandra, would you like to say hello and tell us a little bit about yourself?
Hi, Lucinda. Thanks very much. It's been really exciting. I mean, it's only Monday and we're all really excited. I'm Sandra. I'm from the Observatory Science Centre down in Hurstmoor Zoo in East Sussex, and we're the former home of the Royal Greenwich Observatory. So we have a very privileged to have some of the largest historic telescopes in the country. So I'm very excited to come into you from there tonight.
Excellent. Wonderful to have you. I know you were with us this morning, so thank you for being with us this evening again to co-host. And I just want to remind our viewers that NAW is going until the 22nd of November, and you can register for our other events at Eventbrite and just search for NAW 2020 or go to our website where you can find local online events to celebrate this week. And if you're with us on tonight on Zoom, you can leave questions for our speakers via the Q&A icon, and I see that some of you already have, well done. Or on YouTube, if you're joining us with our live stream this evening, there is a chat box there, which we will be monitoring, and we'll feed those to our speakers as well. So I am going to hand it back to my wonderful co-host, Dr. Vosser, to introduce to you this evening our two speakers. Sandra, on to you.
Oh, great. Thanks very much, Lucinda. I'm very excited to introduce Martin Griffiths and Charles Cockell, who are going to be speaking to us tonight, and then there's going to be plenty of time afterwards for question and discussion. So first off, Martin Griffiths. He's an astronomer and science presenter at Dark Sky Wales and is the director of the Brecon Beacons Observatory. He has been interested in astronomy from a young age and has enjoyed a varied academic career in astronomy and astrobiology, and has a special interest in Mars. And then following Martin, we have Charles Cockell, who is Professor of Astrobiology at the University of Edinburgh. His interests encompass life in extreme environments and the habitability of extraterrestrial environments. So I'm going to hand over to you, Martin. Thank you.
Okay. Well, the big question, is there life on Mars? It all started really back in the 19th century with the observations of this young man here. His name is Giovanni Schiaparelli. And in the 1877 opposition of Mars, he noticed that there were particular things that he called canali on the surface, which is just Italian for channels. But the problem is that it doesn't really translate that well into English, and it started a furore. Were there intelligent things on Mars? The interesting thing about any sort of channels, canals, canali, whatever you want to call them, is that they obviously come up with the idea of water. Is there water on the red planet? Well, of course, today we know that there is, but back in Schiaparelli's day, nobody really knew that at all. So it engendered a whole host of telescopes being built and pointed at the red planet in the next few oppositions. And of course, the one person who really put Mars on the map was Percival Lowell, a Bostonian diplomat turned astronomer, who went out to Flagstaff in Arizona and built a huge telescope and dome on Mars Hill. And here he is at the prime focus of the 23-inch telescope. He really popularized the idea of life on Mars elsewhere and wrote several books, Mars and its Canals being one of them. And the problem that we had, of course, is that well, if there's intelligence, which side of the telescope is it on? Because he kept the whole idea of life on Mars in the forefront of the public mentality. And with press releases like this one, Martians build 2 immense canals in 2 years. Was he actually seeing things on the surface? Were there really Martians there? What sort of Martians were they? were they anything like the ones that H.G. Wells wrote about, for instance? Because Wells was certainly influenced by him, and I'm sure that later on in the series of talks, there will be others coming along. So it's a case of that water may have been there, the canals may have been there. Certainly the public were now intrigued by the whole idea of life on the red planet. And of course, when you have a look at the kind of globes that he put together, you can see very little resemblance, to be fair, to the globes on the right hand side, to what we actually know them to be like on the left hand side. Where are all these canals with all this life-giving water? Well, of course, the canal controversy was exploded by E.M. Antoniadi in 1924, and the canals eventually went away. The problem was the idea of life on Mars didn't go away. And that's a good thing, for the simple reason that we can't rule out life on the red planet. We just simply do not know enough about it as yet. But that water is the key to it all, because most astrobiologists think that water is one of the best solvents for any form of life. And of course, as a molecule, it's absolutely abundant throughout the interstellar medium. We find it all across space. It's one of the most abundant molecules there is. And so any planet forming will, of course, have water from its forming nebula anyway. So was Mars like this in the dim and distant past? Well, possibly. We can only go with artists' impressions of what Mars could have looked like in the past. We know that there are depressions, there are areas there which resemble very, very much river valleys, lakes, possibly even ocean bottoms. Not that we're saying that the oceans are going to be particularly deep in comparison to those here on Earth, probably at most several hundred meters perhaps. But the whole idea of water in Mars's warm and wet past is certainly a reality from what we've been able to see on the planet that's left behind through spacecraft and rovers such as Curiosity, Spirit, Opportunity, and so many others that have visited the planet or are in fact still in orbit around it. So a warm and wet Mars was definitely there in the past. It would have had a thicker atmosphere. It would have had all kinds of interesting materials there, certainly enough minerals on Mars, just like there is here on Earth, to produce life forms. But we don't know if this is the case. And that's the thing that gets us as astrobiologists, as astronomers. We want to know. We just want to know. And so we have to send spacecraft to Mars. Ultimately, perhaps the best thing to do would be to send men or women to Mars to make an ultimate determination. But this warm, wet planet of the deep past is certainly a reality as far as our spacecraft can show us. Now, when we look today, we know that Mars is a very, very dry place, very much like some of the Antarctic dry valleys, only without the snow. There's certainly snow at the poles and on some of the very high mountains like Olympus Mons, Pavonis Mons, Arsia Mons, places like that. But that's a seasonal sort of thing. But wherever we look, we do see the signature of water. And here in some of the canyons that leach out from around some of the craters, we can certainly see gullies that have changed in their appearance for the simple reason that there may be sublimation of ices just under the surface. We know that there is probably water deeper under the surface as far as we can tell, but of course we need to drill down and prove that. But the fact that these gullies are there and that there is runoff at some point, whether it be just icy sublimated dust and things like that, we're not absolutely sure. We need to go there and determine that kind of thing. But then with Curiosity and Gale Crater, we know that Gale Crater certainly had a lake bed at one time in the distant past. We can see the evidence of that all around Curiosity and from the sedimentary rocks that it drills into as well. So the potential is certainly there for life on Mars if life follows the water. The great thing about life is that if it does take a hold, It's extremely tenacious. We know that our planet has been through several huge convulsions which have resulted in mass extinctions. Mars obviously has gone through much larger convulsions than we have. But if it ever had life there, then the possibility of retaining that life is obviously going to be something that is of interest to us, for the simple reason that we want to know if there's life there. We want to know if we are not the only ones, perhaps in the solar system, but certainly not in our galaxy. We're not saying that there's intelligent life on Mars, because life here on Earth is dominated anyway by microbes. And so it could well be a case that, you know, Martian biota are microbe dominated anyway. So Spirit, Opportunity, they found these tiny little hematite balls. There's all sorts of interesting things, the blueberries that they found there as well, which suggest that these things were rolled about in rivers. You can see from the rocks just in this picture here that they are sediments that have been laid down and then scoured away because of the differences in the layering there. So we know that there was definitely water in abundance on the red planet in the past. And wherever these spacecraft have gone, they've dug up some interesting materials. This is one where there could have been hot springs in the Martian past. Spirit has found an area here, 90% silica, which is one of the things that does come out of hot vents. We would expect to have found hot vents on Mars if there was water there in the past, for the simple reason Mars was highly volcanic, just as the Earth is. The problem is now is that the volcanism has probably been turned off, and nothing much has happened on Mars in that way, possibly for 100 million years or possibly more. We just don't know. But there's evidence of hydrothermal activity. And of course, from what we know of our own planet, it's quite possible that hydrothermal vents here were the basis for life on our planet. We know from alkali hot vents and from what we call white smokers rather than black smokers, ones that have cooled down, that the potential for the porosity of these rocks to hold on to chemicals that sort of percolate through them would be very, very good. So this is an intriguing area of Mars that would be worth looking at some point. Now, of course, the strongest evidence yet, the planet might have supported life. Well, according to this, the ingredients for life could be in a zone up to 5 kilometers down for much of the planet's history. That's a long way to drill if we're going to go down into that. So we shall just have to see, to be honest, if we can get down to that sort of layer, or do we have to go so deep? We can see clay carbonate layers in this particular image here. And of course, we can see them step down as well from mountain surfaces onto valley plains. This is 2013. It's a 7-year-old story. We've been updated since then anyway. And of course, back in the 90s, we had all the furore over ALH 84001 and whatever is inside it. We're not saying that this is evidence of life at all, because we just do not know. We just don't. But it's likely that it could be something. It contains crystal aggregates known to be produced by bacteria. It looks like fossil cyanobacteria, but we don't know. Fine-grained particles of magnetite, carbonates, oxides, complex hydrocarbons. Yeah, but this thing is not alive. And therefore, we need to go to the planet to have a good look. And of course, we are intrigued by methane sources and sinks. The methane outgassing is seasonal. It could come from underlying rocks. It could come from microbes, organisms. We don't know. We have to capture enough of it to make some sort of determination. So with water, the potential there in the past for the growth of life, the potential of hot springs, the potential of all the chemistry necessary for life being there on Mars as a terrestrial planet, just like the Earth. Of course, we could well be in for a surprise. There could be something alive on Mars, which would be absolutely fantastic. So we've got to go and have a look, haven't we? And we're sending yet another probe, Perseverance. Curiosity itself has found sulfur, nitrogen, oxygen, phosphorus, and carbon, as well as clay minerals. So yes, there was an aqueous environment, a lake, a stream bed, low salinity, neutral acidity, that's water. Confirmation once again. But we've got enough confirmation. What we want is to go there, you see, and try and find this kind of thing out. So let me have a look. What have we got from our past? Well, we started off with a rather interesting idea by Giovanni Schiaparelli that there could have been canals there. Science fiction writers have run with that ever since. And I love this piece from the Martian Chronicles by Ray Bradbury of Martians, human explorers on Mars for the first time. The party moved out into the moonlight silently. They made their way to the outer rim of the dreaming dead city in the light of the racing twin moons. Their shadows under them were double shadows. They did not breathe, or seemed not to, perhaps for several minutes. They were waiting for something to stir in the dead city, some grey form to rise, some ancient ancestral shape to come galloping across the vacant sea bottom on an ancient armoured steed of impossible lineage, of unbelievable derivation. And that picture of life on Mars has stuck with me since I was a small boy. But at this point, I'm going to hand over to an expert. This will be Professor Charles Cockell at Edinburgh University, who will explore this theme a little bit more.
Thank you very much, Martin. And I think you're the expert, actually. That was fantastic. Thank you. And I'm going to follow on with some related comments. Let me try and share my screen. The first stage of online speaking, to get this bit working. Can you see that?
Yes.
Good. Good. Well, first of all, thank you, Lucinda, for inviting me to speak this evening. It's really excellent to be at this event. It seems, I should say, to have been really successful over the last few days. And I want to talk about this rather curious title to my talk, The Search for No Life on Mars. And in about 10 minutes, I just want to convince you that the discovery of no life on Mars would be extraordinarily exciting. Now, let me make two comments briefly. First of all, of course, it's difficult to prove no life on Mars, but we could go to the most promising environments on Mars that appear to be habitable, some of those environments that Martin discussed, like ancient lakes and ancient rivers and salt deposits, and find no evidence for life. And we could arrive at some statistically robust view that it's likely that Mars has remained uninhabited. So I want to explain why that would be actually tremendously exciting. The other point I want to make, which I think is important that we often lose sight of, is that the search for life on Mars is the testing of a scientific hypothesis, right? The hypothesis is there's life on Mars. The null hypothesis is there's no life on Mars. And scientists should be completely neutral about which one of those turns out to be correct. And they should be equally excited by both, because each one of those leads to a new set of questions. We often get into this idea of a hunt for life on Mars, a search for life on Mars, as if we don't find evidence for life on Mars, somehow we will have failed in some treasure hunt. Search for life on Mars is not a treasure hunt. It's a testing of a scientific hypothesis in a completely objective way. So that's a bit of a rant, a scientist rant, but I think it's an important one, because we mustn't get beguiled by this idea that all we want to do is find life on Mars, and if we don't find it, well, everything's going to be less exciting. So first of all, it's worth pointing out, and this is really just a recapitulation of what Martin said, that there is plenty of evidence for habitable environments on Mars. This is a beautiful sedimentary structure imaged by the Curiosity rover. You can see these nice curled sediments that were formed in Gale crater in a lake that may have had persistent water for potentially millions of years. And those deposits were laid down in the Noachian sometime around 3.5 billion years ago to just over 4 billion years ago, at a time on Mars where we know the surface had a much more abundant liquid water, but intriguingly, the time when we begin to see tentative, albeit controversial, evidence for life in the rock record on the Earth. In other words, there seems to have been abundant liquid water on Mars when there is reasonable evidence that life was emerging, at least beginning to emerge on a planetary scale on Earth, which of course raises questions about, even if there was no origin of life on Mars, could it have been transferred from a planet that we know had life at that time? This water continues into the Hesperian. These are catastrophic outflow channels, beautiful vintage image, and no one shows these days, which I think is a pity, from the Viking orbiters, but I think they're still beautiful. You can see these teardrop shapes around craters, unequivocal evidence going right back to the 1970s of liquid water on ancient Mars. So of course, the presence of liquid water on Mars has actually been known for a long time, only demonstrated on the surface, at least, relatively recently. And Martin also covered some of the other evidence for liquid water very nicely, and this is just a slide to show you that all the other things that life needs to persist in a planetary environment seem to exist on Mars. Carbon from carbon dioxide, so these are the CHNOPS elements, hydrogen in water and possibly in organics, nitrogen has been detected in fixed states such as ammonium and nitrates, and possibly other compounds in the soil, oxygen in carbon dioxide, water, sulfates, oxides, so on, phosphorus in apatite, sulfur in sulfate minerals, and so on and so forth. The point is that the CHNOPS elements, those 6 minimal elements required for life, are to be found in abundance on Mars in different types of locations. There are also many other elements in volcanic rocks. So those are the raw materials of life. We know there was plenty of liquid water in the early history of Mars, and also there's plenty of evidence for energy. There's redox couples, in other words, different oxidation and reduction states of iron, sulfur, organics, and other elements and compounds that we know on the Earth can be used to extract free energy from the universe, in this case from the Martian environment. So here we have it, lots of possible energy, raw materials, and liquid water, the 3 basic requirements for life. And so this is why, of course, needless to say, we are enthusiastic about looking for life on Mars, because we know that on the Earth, anywhere where we find those sorts of raw materials, for example, in basaltic environments, basalt being the major mineral on Mars, we find life. And this is just some scanning electron images of some microbes chomping away on volcanic rock in Iceland from some work that we did now a while ago. Gosh, this would have been about 10 years ago now, 12 years ago. But microbes love volcanic rock, and give them a bit of water and some nutrients, they start eating it. So we know, or have good evidence, that the surface of Mars was at least habitable. The question is, was there any life to take advantage of habitable conditions? And these are the sorts of places that we might look. Again, really just covering what Martin said, so I won't spend too long on this. Ancient rivers, he showed hydrothermal deposits. There are ancient lakes, such as Gale Crater, and ancient hypersaline deposits, things like sodium chloride deposits in craters. We know that sodium chloride deposits or lakes are suitable places for life on Earth. There's no shortage of places to go and look for evidence of ancient life on Mars, and possibly even in the present day, we might look beneath the surface for bodies of liquid water beneath the surface that are trapped at a pressure that's higher than the triple point, the pressure at the surface where liquid water cannot persist. So even in the present day, liquid water might support some type of life. So you can see there's plenty of reason for optimism. You can see why people get enthusiastic about the search for life on Mars, and why people tilt towards this. We're going to go and hunt for life on Mars, and we've got a really good chance of finding it. But I think that we should also think about what happens if we return samples from Mars and from some of these very suitable locations for life, and we find nothing. And this is the sort of punchline of my talk. And I want you just to have a think about these. If we don't find life in any of these places, it doesn't prove a lack of life, but it could suggest 3 possible things that would be of enormous interest to scientists. That life never originated on Mars, in which case we would have to answer the question, why not? What was missing? We've got volcanic environments, we've got liquid water, got all the raw materials and energy. And you can think up of various ideas, but we don't have time to discuss this now. But here's just one example. If you're one of these people who thinks that life originated in hydrothermal vents, which are associated with the edges of tectonic plates, perhaps no such suitable deep ocean environments ever existed on Mars. The presence of an ocean on Mars remains controversial. If the origin of life really did occur in hydrothermal vents, perhaps this never occurred on the surface or in the interior of water bodies of Mars. Maybe, despite those raw materials, there was some vital ingredient that's required for the origin of life that was missing. So the discovery of apparently no life on Mars would raise fascinating questions about the origin of life and what was missing on Mars that was present on the Earth. And in many ways, that would be much more exciting than just finding a bunch of methanogens on Mars chomping away on rocks, which would be relatively uninteresting. So the origin of life happened twice, but what would be much more interesting is to find that it didn't happen and then try and work out why. If we could find no evidence for life, it would also have to suggest that life was never transferred to Mars, that Earth became this fecund environment covered in biology, but it was never transferred to Mars. And we would have to answer the question of why would that be the case when we know that Earth and Mars transfer meteoritic material. Martin showed the picture of ALH 84001. We know that meteorites are transferred between Mars and Earth, in which case, why didn't life make it from Earth to the Mars? Maybe microbes just don't retain viability for long enough in the space environment, or maybe there's a very low probability that when they arrive on the surface of Mars, they find conditions that are suitable for propagation and expansion across an entire planetary surface. It would be a fascinating thing to discover that Mars, although it had conditions that were very similar to the early Earth, it would be fascinating to discover that that planet remains sterile, and yet its sister planet Earth became covered in, today we think, about 10 to the 29, 10 to the 30 microorganisms. That dichotomy of biological history would be truly a fascinating thing to discover. It could also be that life was there, but there was very little of it, and many places remain uninhabited. In other words, there's a little bit of life somewhere buried beneath the surface, but it never got out into these habitable locations, these ancient lakes, salt deposits, and so on and so forth. And we would then have to answer the question, well, why not? What stopped it from being distributed? And there are a number of possibilities. Maybe the water cycle on Mars just wasn't vigorous enough to bring up many of these microbes and distribute them to habitable environments. Maybe they got locked beneath the surface under a layer of permafrost and disconnected from many of these surface ancient habitable environments that we find today. So we would learn a lot about the transmission of life through planetary environments and across planetary surfaces by looking at the surface of Mars and trying to understand why life was not propagated. So what's my purpose here? My purpose here, to get to the punchline, is I just wanted to spend this evening diverting your mind away from an obsessive search or hunt for life on Mars and try and just make the scientific point to remind you that we're testing a hypothesis, including the null hypothesis of no life on Mars. And that if we have found apparently no life on Mars, at least no good evidence in all the places we might expect it, this would in fact be a thrilling thing. And it would force us to address new questions about the origin of life, its capacity to transfer between planets, and its capacity to spread across a planet. So even on a life-bearing Mars, habitable but uninhabited locations would teach us much about life on the Earth, in the universe. And just to labor the point, if we found methanogens on Mars, chomping away on hydrogen and carbon dioxide and producing methane, that might actually be something we would expect. If you've got those raw materials, you would end up with methanogens. So you could say that finding microbial life on Mars would be a sort of unsurprising and rather dull outcome. But finding that our sister planet was similar to our planet, but it has remained sterile throughout its whole history, would, I think, be a fascinating thing to discover. So that's my, I wouldn't say a pitch. Science isn't about making pitches. That's my my plea for you to take an interest in the possibly fascinating outcome of finding no apparent evidence of life on Mars. So thank you very much. And I'm going to, I think, unshare my screen now.
Yeah, great, fantastic. Good to start us off, both of you. So you go ahead and turn on your camera now, Martin. We've got plenty of time for questions. I'm going to remove all our spotlights so that we all share the screen. So just waiting for Martin Griffiths to turn his camera on to join us for a Q&A here. Lots of questions coming in on YouTube and on Zoom.
Hey.
Okay. All right. So great. We're all here and we've got some questions coming in. So one question, I know, Martin, thank you for answering some of those beforehand, but I wanted to ask both of you these questions. So to give you both an opportunity to respond. And I think the first one, which is a really good question, what is a Martian? You know, I think there's a difference between what we expect it to be and what it actually might be. So, what's your answer to something about what is Martian or what is life?
Do you want me to go?
Go ahead, Marcy.
Both of you,
Um,
one each.
A Martian, I suppose, is obviously somebody who comes from Mars. But what I love about the writing of Wells is that he introduced the first true alien. Throughout science fiction up until that point, aliens had always looked like us. They might be gigantic, but effectively they've been humanoid. And Wells is, large bulk, glistening like wet leather, rounded, larger than a bear, lipless mouth, slavering and quivering with snake-like tentacles writhing, is the epitome of something different. And I think that life on Mars, if ever we found anything of that sort of nature, would of course be extremely different to us. But we found no evidence of anything like that. So I think that any Martians are necessarily going to be microbial if they exist at all.
I would say that, yeah, I think that's a nice way of putting it. I think, really what we're interested in doing is finding other examples of life in the universe. And of course, that comes back to what is life, and we could have a 6-hour discussion about that. But for the sake of this evening, let's decide it's replicating evolving lumps of matter. And if that's what you're interested in finding, which I think is probably what most biologists would say they're interested in finding, a Martian is any instance of that type of matter on that planet, whether it's originated there as a true Martian, like an independent origin of life on Mars, or whether it transferred there and it's been there for a few billion years, evolving under Martian conditions. Either way, it would be very interesting. So I think a Martian is an instance of replicating evolving matter that we call life on that planet in all of its whatever manifestations it appears in.
What kind of signatures, because we just had this incredible announcement of phosphenes on Venus, and some people might just think, well, what are we going to look for if we find life on Mars? Are we going to look for large amounts of carbon dioxide? Well, we already have that. Are we going to look for oxygen? What do you think might give us the most obvious sign of life?
I think that you have to look, of course, based on what you currently understand in science. One should always keep an open mind. Who knows, there's not some other type of life made of a different element like silicon. People often are enthusiastic about bringing up these ideas. So one should always keep an open mind just in case you find something completely unexpected. But of course, life is bounded by the laws of physics, and it uses certain types of elements to extract free energy from the environment. And this results in biosignatures, like, for example, complex chain-like compounds from which life is found. Life likes to bolt things together like building blocks to make more complex structures. So biosignatures of life are molecules that you would not expect to be formed by purely chemical processes. They're gases. You mentioned oxygen, could be other gases. Many of these gases are produced non-biologically, but when you see them at high concentrations where you don't expect to see them with geology, you should be suspicious. So I think the sorts of signatures you would be looking for on Mars are these signatures of complexity, of disequilibria, of things that are not in chemical equilibrium that you'd expect purely from geology. And many of those things are bounded by the laws of physics and can be predicted, even if we don't necessarily make any claim to understanding the structure of that life, the biochemical structure of that life, which could be alien.
And that's why I asked that question, just to have the audience keep that open mind and understand that, kind of what we think of, always have thought of what life might be. Of course, all we have to compare it to is ourselves or what we see here on Earth. There's so much more to learn about what's out there in our solar system and in the universe that I agree with you. Keep an open mind. Let's use the scientific method and find out more. I'm going to go to some of our questions in the Q&A because there's lots of questions here. If Earth is the second place life began, he's wondering, where might it have originally come from?
There are several answers to that. If Mars ever had life on it, then as Charles brought out in his talk, we could have transferred between the two planets from meteorites and bombardment and things like that. But it's not the only scenario that scientists think of. There is still a sort of open question on something called panspermia, where life may have come from somewhere else outside of the solar system and seeded the solar nebula and then settled down on planets here. I'm not a particular proponent of that particular idea, but it still remains within the realm of possibility. We can't really rule it out because we have no evidence either way, so it remains an open question. But within the solar system itself, if life developed here on Earth, it could have gone to Venus with early encounters with asteroids and meteorites, and of course it could have been blasted out enough to go to Mars, and vice versa. It's much easier for any body within the solar system to have material blasted off it to come in toward the sun, because that obviously is the largest gravitational source in the solar system. So if life developed on Mars, we could well pick up some of it here on Earth, and vice versa is also a possibility.
Charles, did you want to weigh in on that?
Yeah, no, I would echo Martin's comments. Obviously, it remains an open question as to whether there are other bodies in the solar system that have life, let alone being habitable. If they do, I think the question of whether life could be transferred between planets remains a really interesting one. Of course, as Martin rightly points out, it doesn't solve your problem in terms of explaining the origin of life. It just pushes it somewhere else. You still need to get behind that chemistry, but it's a legitimate question to ask whether life could have been transferred between planets and whether it has been. And I should say, panspermia has a slightly outlandish reputation, but of course it's an old question. It falls under what ecologists would call island biogeography. We know that life is transferred from one part of a continent to another, and life transfers from one continent to another. It's just island biogeography on an interplanetary scale. Are islands biogeographical islands, or do they transfer life? So there's nothing really controversial about the question of whether life could be transferred between planets. One just has to be careful about keeping it within the realms of science and not getting too carried away with ideas that there are lots of rocks and planetary bodies out there that are at the current time transferring life. That remains an open question.
Yeah, there's still more to learn and more to discover. Absolutely. And so I'm going to go to a question about the future possibilities of Mars, life on Mars. And there's a lot of questions out there about, what would microbial life, if it ever evolved on Mars, be like, and things like that. But this question is asked, do you think that at some point in the future, will we be able to live and create a stable life on Mars? Maybe I'm going too quickly to this idea of terraformation, but it is an interesting question.
Go on, Charles.
Okay. Well, terraforming is, of course, hugely ambitious. And I don't think anyone has come up yet with a viable scheme that would transform the Martian environment into an Earth-like environment in any reasonable length of time anyway, or in a way that is predictable. But it's a fascinating idea. Of course, we're currently Venus forming the Earth. We know how to alter our planet, not quite that extreme, but we're sort of moving in our small way towards that direction of increasing CO2. So we do know how to alter planetary atmospheres on planetary scales. We are in the process of doing planetary scale engineering, but I think doing that to Mars and transforming it into an Earth-like environment is ambitious. But I'm fully in favor of localized terraforming in the sense of constructing stations on the surface of Mars and building self-sustaining habitats on the surface of Mars, in which we can build an independent human settlement on the surface of Mars. In fact, I'm a great enthusiast of that. So I think that's coming up in the nearer term than terraforming. I think the reality is someone needs to come up with a credible way to terraform Mars in a period of time that's not geological.
I think with CRISPR and then terraforming Mars, I think there's like a 1,000-year plan. Even Buzz Aldrin published that from National Geographic in his book, right?
Yes.
Yeah, it's going to take hundreds of years, exactly. Here's a question about astrobiology research. Do you recommend going to Mars to conduct more efficient astrobiology research? And I'm guessing they meant humans to Mars. Or should we hold off because of the contamination risks? Because the rovers on Mars are doing, the Perseverance going there is going to be caching life, possibly looking for life on Mars. But what about bringing those those parcels back? That's also in the works. So what about contamination risks?
Contamination risk is always a problem. The thing is, if you're going to send people to Mars, then obviously, the suits are going to have to be sterilized in some way every time that they use them, just to eliminate that kind of risk. But then, having said that, if we do take this kind of life to Mars, it's going to be fairly easy to see that it's something that we've brought as well. If we are looking for Martian biota, necessarily very small Martian biota, I hope that it will be fairly distinct from anything that we would bring there. And because of the values within evolution, although we may see some parallels, I don't think that we're going to see an exact match to anything that we could bring to the planet. Our problem would be, would those microbes like Mars too much and then remove the indigenous biota? And that is a serious problem that still has to be addressed properly.
Yeah, I don't have much to add. I agree with that. I think there needs to be caution, and we need to be careful with how we explore. I'm not of the view that the possible presence of subsurface life on Mars needs to stop human exploration. As Martin said, I think we could distinguish between them. The other analogy I would give, from a microbiological point of view, if I said, oh, I should be careful about this bottle of water on my desk, because if I drop it on the floor, I might destroy the deep subsurface biosphere under Edinburgh, people would think that was a very strange thing to say. So there's very little connection, or there is connection, but there's very long-term geological connection, say, between the surface and the deep subsurface. Even if there was life in the deep subsurface of Mars today, I suspect you could construct a station on the surface without threatening a planetary scale biosphere in the deep subsurface. But never say never. No one wants to be responsible for destroying an entire planetary biosphere. So we should be cautious about how we explore Mars, particularly doing activities that create large-scale contamination.
Yes, that's what we have the Planetary Protection people for, right? To consider those possibilities. And I'm sure they're thinking about those cache samples that Perseverance is going to one day, or whatever object's going to bring those back to Earth, how we're going to handle them. Well, I mean, you're talking about subsurface here in your example, and we've got a question about someone who's curious to know if minerals found 5 kilometers down in the 2013 study, because Martin mentioned this in his talk, and if they lie at the same or similar depth and location as the recently detected subterranean brine lakes on Mars' southern hemisphere, they were curious to know if the minerals found 5 kilometers down were same or similar in depth and location. I think that's their question.
Okay, to be honest, the study wasn't brilliant. It was reported in the BBC that we've obviously got this material 5 kilometers down. It was speculative more than anything else, because obviously we haven't been 5 kilometers down under the Martian surface. But what they could see from orbiters and from returns of orbiters was that there was the probability that these minerals would survive there at that sort of depth. And as Charles has said, the interface between the surface and the underlying geology is going to take a long time to sort of get percolate through cracks or anything like that. So we're not absolutely sure that the materials 5 kilometers down under the Martian surface are going to be life-bearing things, but the possibility remains that they could be. We can't live on the surface of Mars, no microbe can anyway, because there's no atmospheric shielding and no magnetic field to stop cosmic rays or solar bombardment. And so any life would necessarily have to be subsurface anyway. Now here on Earth, we're finding life in all kinds of environments, deep underground as well. And as Charles showed in his particular presentation there, we're finding basalts here which are being chewed up by microbes, and even in drilling now for oil and other minerals deep down, we're beginning to find that life here on Earth penetrates down into the deep subsurface as well. So it's possible that if life ever occurred on Mars in the deep past, then that has happened too there, and it's escaped from the surface down into the subsurface area, but it remains a speculation.
Charles, did you want to weigh in?
No, I think that's a good summary. I guess the only thing I might add is that the saline lakes that I think were referenced in that question, they are in the polar ice caps, so trapped beneath the ice layers of the poles, and the temperatures of those lakes are probably going to be about -60. So you need very high concentrations of perchlorate to maintain liquid water. So those lakes are at a temperature that is well below the lowest temperature that's been recorded for the reproduction of life. And the perchlorate ion concentrations needed to keep that water liquid are far more toxic than anything that's been shown for life. So if it is liquid water, it's uninhabitable. And it raises this interesting question that, people often say where there's water, there's life. Life definitely needs liquid water, but it's not always the case that where there's liquid water, it's habitable. You can have uninhabitable liquid water, and concentrated perchlorate brines at -60 are an example of likely uninhabitable liquid water. So we shouldn't get overexcited about liquid water.
Good point. So you, in your talk, Professor Coquelle, you mentioned, you had this title of no life on Mars. So someone's asking a really great question. Richard wants to know, how long will it take to answer your hypothesis of no life on Mars?
That's a good question, and without getting into technicalities, but you can use things like Bayesian statistics that allow you to put some probability. So let's say you go to Mars and you collect 50 samples from a lake, different lakes across the planet, and none of them have life. And you do the same thing in rivers and hydrothermal vents, and none of these things show up life. You can then use, for example, you could say, well, if Mars did have life, what would be the probability that I would, by chance, select 100 samples, none of which have life? And life is patchy on the Earth. You can pick up a rock that's got no life in it. So you can use that knowledge to come up with some statistical probability that you would expect to collect 100 samples, none of which had life on a life-bearing planet. And by using those sorts of approaches, you can reach some sort of probability. You can say, well, I'm 96% sure that this planet is uninhabitable, or the chances of picking 100 samples with no life on a planet that had some sort of life like the early Earth would be something like less than 0.001. So you can never reach certainty, but I mean, that's the case with a lot of things in science. It's about putting probabilities on things, but you can use these statistical methods and you could come up with some sense that, well, we're now as confident as we can be that this planet never hosted life. But of course, as I say, maybe there's some little oasis of life deep beneath the surface. But having said that, that's sort of unlikely, because once you have life on a planet, it does tend to move through water courses and through fractures and colonize habitable spaces. It was probably unlikely you'd have a planet where there's just one patch of life sitting there and it never went anywhere else. So these sorts of considerations come into play as well. So it's not a simple thing. It's a really good question.
Martin, did you want to say anything to that?
No, I think that Charles has covered that very well, actually. There's nothing really I can say to that.
Well, I was on Charles' talk anyway about no life on Mars, but planetary protection and life. And there's lots of questions here about humans to Mars. I'm really quite surprised. We are going to talk about humans to Mars on the last day of NAW. So there is a lot of interest in this. And that's the burning question is there other life out there in our solar system, in the universe? And so my sort of devil's advocate question is always, what if there is no life, that's close enough for us, because we're doing all this work to see if we can find life that's nearby. But what if we need to just move a little bit further outward, and maybe Mars is that first stepping stone to getting humans further out there with technology to look for the search for life? But what if we are the intelligent life? What if there isn't anyone out there to communicate with, or they're waiting for us to get closer? I mean, what about that question with life?
Do you want to go, Charles?
Okay. I'll give you an analogy, which I often try and give people about this question. If I said to you, I'd really like to see what civilization is going to be like in 1,000 years, but unfortunately I'm going to be dead. You're not going to come up to me and say, stop being so negative about your future. You should be more positive. It's just a fact of life, and you come to accept that at some point in your life, your mortality. And that sounds like a strange thing to say. The reason why I'm making that is because that point is because it might well be that there is either no intelligent life elsewhere in the universe, or if it's out there, it's so far away for all intents and purposes, given the limitations of the speed of light, we will never come into contact with extraterrestrial intelligence. And so it might be that we're still in our sort of Star Trek adolescent youth, where we're convinced that we will talk to aliens. It's just a matter of time and technology. And we've yet to confront the potential reality that we will die on this planet, or at least in our solar system, and perhaps some nearby stars, but we will never come into contact with another intelligence. This is something that people adamantly refuse to accept, this possibility, that this is not about negativism. It's just a reality of the life of our civilization, that we will never talk to other aliens. And maybe out there in the universe, there's a dense star cluster where there are 2 stars that have given rise to 2 civilizations. And so some aliens out there have had the wondrous experience of first contact. It may have happened in the universe, but maybe it's not going to happen to us. Maybe we're just in a fairly rubbish area of a fairly average galaxy. And that's the reality. We're going to die. Our civilization is going to die without making contact. That's not negative. It's not depressing. It might just be a reality. So I would say that I don't know what the consequences of that is. I'm not sure what to say about it. It's just the way it might be. And we may, in the next few hundred years, have to confront this reality.
Yeah, I agree with Charles. It's a case of, I believe that there is intelligent life in the cosmos beside us. But the problem is, when we have a look back at our own evolution and the evolutionary history of Earth, there are very, very few, if just one species, has ever developed intelligence enough to produce technology, and that's us. So it's a case of, I think that intelligent life out there is going to be extremely rare, and we'll never, ever get to know about it, because that rarity precludes us contacting one another, despite the fact that we might have the same ideas, or at least we would want to reach out. We could be so far apart from each other that if we had another life form, intelligent life form in the Andromeda galaxy, we could send a signal to it, and we're not going to hear from them for a long, long time. Back in 1974, Frank Drake and Carl Sagan did this with the globular star cluster Messier 13. Well, if there is an intelligent species that picks up our message on a planet going around any one of the stars in Messier 13, we should hear about it sometime in the 58th millennium. You know, I mean, that's just ridiculous. Nobody's going to wait around for that kind of thing. So I think that Charles is right. We have to face the reality of it, that it's a question that we would like answered because it's something that presses on us. But we may, in 1,000 years, be mature enough as a species, if we last that long, to think, okay, we've done this, we've got the T-shirt, we will now come back a little bit, address some of the problems that we've got here, and then perhaps look outward. We might have gone to planet Mars by then and settled it, and as Charles said, we might have colonies, we might have this, we might have that. You know, the answer to life in the universe could well lie within our own solar system in places like Europa or Ganymede or Enceladus or places like that. So it's a case of we have to start nearby before we can think of the very large picture of a universe out there. That's ridiculously large. I mean, given our current technology, if we wanted to go to the nearest, you know, Earth-like planet, allegedly, or Earth-sized one around Alpha Centauri, with our current rockets, it's going to take us 138,000 years to get there. I mean, that's not a journey we can undertake. So everything has to be done remotely, and that's going to take a long, long time and a lot of money.
Wow, well, that's probably not the most you know, favorable answer people want to hear at this point. They all want the whole romance of, you know, intelligent life out there. And I am in complete agreement with both of you. I think we are the intelligent life, and we should celebrate that and use, you know, all the faculties that we have to create the technology. But I am biased because I am the executive director of the Mars Society, and we advocate for humans to Mars. But I do.
Yeah.
I'm so positive, and I completely concur that yeah, humans are absolutely capable, and we just might be the intelligent life out there. We still have 6 more minutes this, and there's lots of other questions about biological life and what that might look like. But I had to ask that question. I think I'm just really happy to get that out there, to have people kind of think about that. You know, what is stopping us? My biggest fear is stagnation for human species and for life, you know, period for life period. So it is an ongoing kind of debate about all this, and I'm glad you brought up Martin Enceladus and other, you know, places to explore in our solar system. We're just barely scratching the surface. We do feel like we're moving forward at light speed here, but we're really not. And I'd like people to think about that as well. And it's so interesting because we're learning how vulnerable we are, especially being in the situation we are with a second lockdown here in the UK and a pandemic. So lots of really important things to think about in our own like frailty. Okay, so moving on, definitely a positive force, a positive thing that we're life out here. If life did occur on Mars, how likely is it that it would have had time to evolve? That's one question we have from PETA and Steve Baldwin.
Okay, well, life is evolving all the time. You know, life will always have errors in it, and those errors will be selected in the environment. So evolution is just a fact of anything that replicates in the universe. It's going to evolve. But the question is how far? Well, I don't think much beyond single-celled organisms, just because there isn't the energy supply that we associate with multicellular complex life on the Earth. We think the rise of animals was associated with the rise of oxygen, and certainly the rise of complex multicellular life eventually leading to us seems to be linked to that gas oxygen that provides that electron acceptor, that aerobic respiration that generates so much energy. There isn't that on Mars, at least not in sufficient abundance to probably allow microbes to evolve multicellular structures and beyond. So what we'd be looking for on Mars is prokaryotes, bacteria-like things, archaea-like things that have been sitting there, if they're there at all, for 3 billion years, probably evolving, but not up to much other than being single-celled microbes. When I say not up to much, I'm a microbiologist, so absolutely fascinating. Plenty enough for us to be getting on with. But for those people interested in animals and plants, probably not so interesting.
Yeah, everybody wants to go beyond amoeba. You can't talk to an amoeba, but they remain fascinating even so. And Charles is right, you know. I'm an astronomer by background, but it's a case of, you know, we're always looking outwards and finding it easier to go to these places, and we find life all over the place. But it's not necessarily like that, because life is quite complex. Even the smallest, you know, sort of species of microbes are incredibly, you know, interesting little things with complex lives. They've got complex chemistries, complex interactions, and the way in which they take that energy out of the environment can be done in ways which we find extremely strange, but nevertheless it works for them. And I would expect on Mars, if we ever found them, then they would have evolved from some basic structure up to today.
So here's another question. Assuming the planet is now sterile, so if there is no life on Mars, what would be the evidence for life in the distant past that might still be found today? I know you mentioned Allen Hills, you know, as a possibility of some ancient bacteria.
It would be fossil evidence, possibly direct fossil evidence if it's been well preserved. It would be chemical evidence, isotopic evidence of life. It would be possibly direct search for biomarkers, that the molecules from which life is constructed, so lipids that make up membranes that are very well preserved in the rock record. These are the sorts of things you look for in ancient rocks on Earth to demonstrate the presence of early life on Earth, and you're applying exactly the same principles to the search for life on Mars. In fact, the samples returned from Mars would be processed in much the same way that people look for early life in the terrestrial and the Earth rock record. So yes, these are the sorts of things you'd be looking for.
Yeah, the materials would be very similar to what we find here. So I would expect the same biosignatures in some respects.
So we're nearing the end here, and I'm about to hand over to look at Mars in a second, but I want to give you both an opportunity. This has just been very fascinating. I want to thank you both for being a part of National Astronomy Week. Sure. I'm going to give you an opportunity. Do you have any last words that you'd like to share with our audience about life on Mars?
Martin.
Go on, Charles.
Okay. I don't really have much to say other than stay enthusiastic about Mars, about astrobiology, the human exploration and settlement of space. We have a fantastic future as a civilization ahead of us, and Mars is definitely part of that vision, both fundamental science, search for life, and the human future as well. So keep enthusiastic.
Absolutely. All the way back in 1933, there was a Russian whose motto was "Forward to Mars." And I think we should keep doing that. Go forward.
Excellent. Go forth onto Mars. Thank you both again for a wonderful talks and an evening and Q&A with us. All right, but it's not over yet. We're going to be moving on to, we have some remote observers this evening. And as we have every night of NAW, we're going to be doing some remote observations with astronomers around the UK. Let's see if there's any clear skies. I've got Dave Eagle and Les Brand, who are our hosts this evening. You guys both want to say hello and let us know what might we be looking at tonight.
Yeah, hi everyone. It's Les here from a very wet and unfortunately cloudy Upminster. So we're going to be playing a sort of a segue between our plan A, which was to get out there and actually see the sky, and we will be doing that, but we're going to play around with our plan B as well. So I'm joined here by some other of our astronomers, and I'm just going to show you where they are, these guys. We've got Dave Eagle, who's joining us from the Midlands. If you want to say hi, Dave.
Hello, everybody. Hope you're having a good evening.
And we then have David Bennett and Ryan Parle, who are joining us from Bristol, the Bristol Astronomical Society. Say hi.
Hi there.
I hope you're both there, because I know some little gremlins earlier, but we're over that. But we also have our very special astronomer based all the way over in the Mediterranean, the lucky person. This is Agapios, who's over in Nicosia in Cyprus.
Hello, everyone.
Right, so what we're going to do in a minute is go around and see everybody, have a little introduction, see what we can see in the night sky. As I say, it was really interesting hearing Lucinda and Martin and Charles talking about life on Mars and prerequisites like liquid water. And I think one of the issues is that we've got too much liquid water around us at the moment. So we're going to do our best. We're going to do our best for you. What sort of, I guess, piques our interest here for the whole of National Astronomy Week is the fact that we focus on one topic, and that topic is Mars, because it is so prominent in our night sky. Now, what I would have said to everybody right now is drop what you're doing, rush outside and look up in the southeast, and the most prominent object you would see up there would be Mars. Unfortunately, you can't do that at the moment unless you're lucky enough to be in a place where you've got some nice clear skies. But we're going to take you on a quick tour of that, and you would have heard a lot about different topics on Mars if you've tuned in over the past few days and during today. So what we're going to try and show you is some of the features on Mars, and I'm pretty sure that we're going to have a great surprise from Agapios in a moment. And a lot of what's on Mars has been mapped, certainly in more recent decades, by a lot of the spacecraft that we've sent to Mars. There's been something like, I think, over 50 missions. Not all of them have been successful, but some of the more successful ones have been really taking great images of Mars, actually landing on Mars. We'll hear a little bit more about, and you certainly heard about that. You will be hearing more about that later on in the week as well. But here's some of the features that we can even see some of these from our Earth-based telescopes. And indeed, not just the professional observatories, but amateur astronomers like ourselves that can point our telescopes up to Mars and really start to tease out some of these features. So we're going to be showing those to you. But before we get too far, I think it's time, if we can, to hand over to Agapios in Nicosia and see if you can show us and tell us a little bit about what you're doing over there, what your equipment is. I think you're actually in your observatory. So over to you.
That's right. Hello, everybody. Good evening. Hello from Nicosia. I'm coming to you tonight from the 1010 Observatory in downtown Nicosia. This is a public observatory. We use this for outreach events, for astronomy nights, as well as workshops and presentations on astronomy. Currently, I'm inside the dome, as you can see, side by side to the 14-inch telescope that we have. I have everything lined up on Mars. It's mostly clear. There's just only a little bit of clouds. And I'm going to try now and show you what the live view looks like. Bear with me for a moment. Let me know if you can see my screen.
It looks good.
Coming through great.
Okay, so this is the view right now through the 14-inch telescope. You can see Mars in the center there. We're using a color camera again, and we're getting live views of Mars. And the seeing actually is not too bad. I was able to do a quick capture just before I logged in, and I'm going to pull it up on the screen again and show you sort of detail that we can get. There it is. Can you see that?
Fantastic view there.
Yes, as I said, the seeing conditions were actually pretty good tonight. And although there are only a few clouds, as is the case right now, you can see Mars just dimmed a little bit. But I was able to get some good data to share with you. And there's a whole lot of features that you can pick out from this view. The most obvious one would be the south polar cap, this bright patch you see down at the bottom. I can pick out quite a lot of cloud activity. I'm not sure if this is part of the new dust storm that's currently ongoing on Mars, and a wealth of surface features as well visible. And right over here we have Olympus Mons. Yes, so quite a nice view. Later on, we might try to show the planet Uranus as well.
It's actually amazing, Agapios, the detail that you're managing to get through your scope there. Can you tell us a little bit more about what you're using, what the equipment is?
Yes, absolutely. So as I said, we have a color camera attached onto the telescope. This is a specialized astronomy camera, quite different to a regular photo camera. So this can capture many frames per second, and we essentially record videos of the planets, and we end up with a very large collection of individual pictures taken in very short time spans. And we do this to isolate the best times when the atmosphere is at its most stable. And when we do that, we have a large collection of frames. We can combine all of those together in a process called stacking, and then sharpen that result and come up with something like what you see on the screen now. These cameras are quite fast, so in only a minute, one can capture many, many thousands of frames. In this case, I was able to capture about 6,000 frames in 1 minute. And I went on to isolate the best ones and combine them together and process them for you.
And Agapios, in terms of what we're seeing here, we're obviously seeing a particular face of Mars. There was talk yesterday or a couple of days ago. It's been reported a dust storm is started. It's one of the features of Mars. It's got a sort of quite a thin atmosphere of mainly carbon dioxide, but sufficient temperature variations across the surface and so on that it sort of can whip up quite intense storms and lift up all the dust. So do you think we're starting to see that, or what might happen if that starts to spread across the face?
Well, if we go back to the last apparition of Mars 2 years ago, what happened then was there was a very sudden dust storm that whipped up and ended up covering the entire face of the planet in what's called a global dust storm. And I wouldn't be surprised if this is the case again this year. Thankfully for us observers, this happened much later on in the apparition. The last time this happened, it was very early. But this time it looks like Mars spared us and gave us quite a fantastic apparition this time around. But I wouldn't be surprised if this ends up being another global dust storm, or at least covering most of the planet anyway.
And then, of course, it's as far as as far as any images of Mars are concerned, it's going to be sort of quite murky, as if you're right in the Sahara dust storm. You just wouldn't be able to see many features at all.
Absolutely.
And it's interesting. I think this is the third night that we've been doing live observations. Unfortunately, I think we've seen Mars on every single occasion. The interesting thing about Mars is that it actually spins once on its axis in just a little over 24 hours and 24 and a half hours. So roughly the same, just a little bit longer than Earth. So actually each night this week, we're probably going to end up seeing approximately the same face. But it'll be interesting to see how the features do change if that dust storm does start to make its way across. Probably take quite a few days though to actually start getting around the complete globe.
Yes, I think we're in store for a good show.
Okay. Is there anything else that you can tell us about? How you're doing. What happens next in terms of your imaging?
Well, typically, once I've gathered all of my required data, I usually like to capture for an extended period, roughly about 2 hours. So once I've captured all of my required data, I would then go on and begin the processing. And that typically takes a good amount of time, depending on my free time as well. But after the collection stage, there's many different steps of processing. We have the stacking part, which is the combination of all of the frames. We have the sharpening stage, and then the final post-processing that has to do with cosmetics and minor, enhancements of the image. But a complete processing would take me 2-3 hours to complete and be able to come up with a finalized image.
So I think, Agapius, if you can sort of keep monitoring the situation, I mean, it sounds like you've got beautiful weather over in Cyprus at the moment compared to what we're seeing here in the UK. But if you can keep monitoring that, you mentioned we might have a chance to see Uranus perhaps a little bit later this evening.
Yes, absolutely.
Perfect. Well, I guess what we'll do then is we'll move on, and just before we move on to our next astronomer, I just want to quickly show you what Agapius was just showing in with some of the features. that were highlighted. This is an image that's actually taken from the British Astronomical Association. There's a tool on the website that allows you to see the features on Mars according to date and time and so on. Very, very useful. It's normally sort of inverted, so south's at the top, which is more of a sort of a historical thing, but Agapius's image was actually showing you sort of north at the top and south at the bottom. But you could quite clearly see, as he showed earlier, the South Pole and Olympus Mons, and then we see these sort of lighter areas at the top and the darker areas at the bottom. These are sort of the northern hemisphere was more of a sort of smoother features, probably more lava flows. And I think the two speakers before were talking about telling us about liquid water on Mars and so on. It was thought before we had more information that actually it was the darker areas that would be liquid oceans. It's probably, I think, more the other way around, that the northern hemisphere was where perhaps some of the great oceans were, if liquid water, or where the liquid water would have been. But I think we'll move on now to Dave Eagle. Are you ready?
Yes, I'm ready.
Excellent. Over to you, Dave. Tell us a little bit about where you are yourself and your setup.
Okay, excellent. Okay, well, what I'll do, I shall share my screen. And hopefully you can see my PowerPoint. Okay, so I'm based in the Midlands in Northamptonshire. I'm an amateur astronomer. I run a mobile planetarium, going to schools, a STEM ambassador, and do astrophotography and an author as well. So that's my history. So I was hoping to be able to show some live streaming tonight in two ways. So the first one was this wide angle camera. So it's in a waterproof box here with a dome over it. And there's a little planetary camera similar to the one Agapios had just now. And it's got a wide angle lens on it. And here it is in close up. And that's sitting there looking at the sky. So I'm using this to try and look at for meteors, because we've got a couple of meteor showers coming up. Very soon we've got the Leonids, and then we've got the Geminids, which are going to be much better next month. So I'm hoping to be able to capture some meteors with this. I've only just installed it, but unfortunately this is the view you're going to get tonight, which is complete clouds. So you know, there's lots and lots of clouds up there. But when it is working and you get a clear sky, we can see something like this. So you can see quite a big swathe of sky using this. So this is towards the north, south, west and east, and you might be able to pick up some constellations. Here's one, a nice W shape over there, and that's called Cassiopeia, the Queen. And then over here we've got a cross shape showing there, which is Cygnus. So well-known constellations there, and easy to identify in the night sky. But if we look at some of these stars here, you've got Deneb, the brightest star in Cygnus there, Vega in Lyra, the Lyre, and then over here you've got Altair, which is only just coming into my camera view, in Aquila called Altair. And those three make up what we call the summer triangle. Although it's a summer triangle, it's still visible this time of the year, so get out and have a look at the night sky for those. So the telescope I've been using to image Mars recently is this C11 telescope. It's 11 inches across. It's got a very long focal length. That means it produces quite a big image of the planets, and it's perfect for taking images of the planets. So I've been taking images of Mars and the other planets with that as well. And I use a webcam very similar to the one Agapios showed you. And again, we take a video and then we process that video to get a single image out of the hundreds of images or thousands of images that that video takes. So here's the sort of thing we get, very similar to what Agapios showed you, but of course this is taken from the UK, where Mars isn't quite as high up, and we have more of an unsteady atmosphere. So you can see it jumping about because the Earth's atmosphere is causing it to wobble quite a bit. But you can see some of the features. You can see the polar cap just popping into view every now and again when the scene just steadies, and you can see this big V-shape dark area, which is called Syrtis Major. So that's one of the most distinct features on Mars. So when that rotates into view, you can see that really, really clearly, even in a small telescope. But as you can see, it wobbles about. But as that video is capturing that data, there's lots of data in there. You can't see it, but you can process those images. And then once we processed it using this stacking software and then sharpening, this is what we get out of it. So you can see there's quite a lot of detail in there. We've got the polar cap really nicely. We've got Syrtis Major showing up quite nicely, and some nice features on there as well. But of course, Mars doesn't always stay the same, because the distance between Mars and the Earth does vary. So here's what happened at the beginning of the year. So in January, it was quite small. And then by April, it got a bit bigger. And you can see this was my silly attempt at it back in April. It was really low down, but I thought I'd have a go anyway. You can see the phase, because Mars does show a phase like a gibbous moon just before or after it's full. And then it got bigger and bigger as we approached the summer. So August, after Comet NEOWISE went, was when I started to image it. And you can see here, you can see quite clearly, it's much bigger than the original image. And this polar cap was quite big at that time.
So these are all on the same scale then, Dave?
These are all on these are at the top here. These are simulated images using software called Stellarium. So they're all at the same scale, and I've made my images to the same scale as well to show you what I've managed to capture. So by September, it had got really big. So this is one of my best images taken around that time. You can see quite a lot of detail in there. You see the polar cap is now starting to shrink quite a lot because it's summer in the northern hemisphere of Mars. And you can see Valles Marinaris as well, which is this huge canyon on the surface of Mars. And if that was in Europe, it would cross all the way across Europe. That's how big it is. So it puts the Grand Canyon to shame, really. And then, of course, it was at its best at opposition opposite the sun on the 13th of October. And this is one of the images I took around there. The seeing wasn't as good as it was previously, so I didn't get quite as good an image, even though the disk was a lot bigger at that point. And then, of course, November and December, it's starting to get smaller again. So it's going to get more difficult to get those features as we go. Here's an image I took on the 6th of November, and you see Syrtis Major coming into view once again. And that's what we've got on view at the moment in the evening sky once it gets dark. So that's what Mars is doing at the moment.
So some fantastic images there, Dave, that you've managed to capture, and it also showing you the different faces as Mars is sort of spinning when you're imaging it.
That's right, because you go out at the same night each night, more or less, you'll see more or less the same face. It gets slightly later every night, so you have to bide your time and wait for a good night when you want to get a different part of the planet as well. And of course, it's changing all the time because the distance is changing. So it's really difficult because it is still quite small. But there are two other bright planets visible, and this is tomorrow evening at 5:20. And Jupiter was at its best at opposition opposite the sun on the 14th of July. And this is the view south at about 5:20 tomorrow evening. And you should be able to see two really bright stars. There's Jupiter, which is the brightest one, Saturn next to it, and the moon's just coming into view now as well. So the moon's starting to come back into the evening sky. So look out for that tomorrow evening, a very thin crescent, really low towards the southwest. But we're talking about the planets. So here's an image I took in September of Jupiter, and you can see the cloud belts and zones on there, the dark belts and the bright zones. And if you've got a telescope, get out and have a look, because occasionally the red spot shown here goes across the disk as well. But Jupiter is getting a lot lower in the sky now, so it's getting a bit more difficult. So you can get red spot transits when they go across, and you might be able to see these dark spots going across, and that's actually a shadow of one of the Galilean moons, one of Jupiter's satellites. It creates this really dark shadow, but much more difficult. The satellite going across the disk is much more difficult to see because it's not really that much different brightness from Jupiter. But Jupiter and Saturn are quite low down in the sky, so they do give you a bit more of a challenge. And if I show you a video of Jupiter, these were a couple of views I took a few months ago when we went down to Dorset for a weekend when we were allowed to. And this is the view over the sea, and you can see the Milky Way quite beautifully over here. And there's Jupiter and Saturn, and Jupiter's even got a glitter path on the water in the two images. So fantastic sight if you can get a really dark sky and see the Milky Way with the two planets at the moment.
Just shows you the benefit of a location with little light pollution as well.
Yeah, get away from all the street lights and you see the Milky Way in all its glory. I'm not too bad here because I've not got too many street lights, and the local council just fitted a little shade on my street light as well, which is quite nice. Thank you very much. So that's going to help me. So this is a video of Jupiter I took quite a while ago, and you can see we've got the biggest problem here because it's so low down. It's wobbling about and waving about, and as you can see towards the end of the video it actually starts to fade because the clouds started to come in again. But if you look carefully, you can see to the left of it is one of its moons, Io, just visible there. Wait till it restarts again, then you'll see it pop into view. Yeah, you can see it just there. And surprisingly, when you process that video and do all the sharpening, stacking, etc., this is what you get. So you can see the cloud belts and the zones quite nicely. And of course the other planet down there, oh sorry, yeah, on the 19th of November the moon's going to come a bit further in, so it'll be just above Jupiter and Saturn and the moon, so that will make a nice little sight down there on the 19th of November. And then just to finish off this bit with Saturn was at its best, and that was opposite the Sun on the 20th of July. Here's an image I took in 2018, but the rings, if you look at them, they're starting to close. Here's an image I took in September, and you can see this one in 2018, the rings actually stick up above the globe of the planet, but this year they're actually started to tuck behind. So you can see the rings are actually starting to close up on us now. So they do that every number of years as Saturn goes round in its orbit. The rings close up, open up, close up, open up in both ways. So they're starting to close up again, so they're going to get a little bit more difficult. So again, this is what we see. So you can see, look, it looks nothing like you think it should. It's waving about and wobbling all over the place, but surprisingly, when we process that, stack that and sharpen it, we actually get an image that looks something like that. So it's not too bad at all. And then tomorrow evening, if you look towards the southeast, you'll be able to see Venus. Or tomorrow morning, sorry, 6:20 in the morning, you can see two other planets. You've got Venus and Mercury, but Mercury is really, really low down. You've got to be quick because it's disappearing rapidly. It's moving around the other side of the Sun. Venus is doing the same, but because it's further out from the Sun, it moves much slower in its orbit. So it's moving gradually into the twilight. But get out there at 6:20 if it's clear tomorrow morning, and you'll be able to see those two planets as well. And of course, during lockdown, I was fortunate enough to be able to see Venus approaching the Sun between April and June, and as I was home every day and we had a good run of clear skies, I got a good look at Venus. As you can see, as it got closer to the Earth, it got bigger, and as it got closer to the Sun, it got much thinner in crescent. And that was my last look at it. It actually was closest to the Sun on the 3rd of June when it was way too close to the Sun for me to do that. And then the next time I looked at it was on the 13th of June when it was much thicker crescent, and then it moved away from the Sun. You can see it's starting to get smaller again as the distance from Earth increases. And all these images were taken during the day, so you don't always have to do astronomy at night, but of course there's a big warning here: only do this, you know what you're doing. I have proper filters because the Sun can be quite dangerous if you manage to look at it through binoculars or a telescope or anything. And then just one thing to look out for in the future: on the 21st of December, the winter solstice, if you look really low down towards the southwest at about 5 o'clock in the evening, you'll see an extremely bright star sitting there. Of course it's not, it's actually two planets. It's Jupiter and Saturn. Because Jupiter is moving faster than Saturn, it's actually overtaking it in its orbit. And on that day, Jupiter overtakes it and passes really close. So if you've got a telescope or binoculars, have a look. And this is the view you're going to get. So this is Jupiter, and here's Saturn. You see the shape of the rings there, and Jupiter there. So they're visible in a wide field view, although not that wide a field of view. And some of the moons, Io, Europa, Ganymede, and Callisto. And really difficult is going to be Titan because it is low down in the twilight. So 21st of December, get out and have a look. Make sure you've got a really low horizon to the southwest and see if you can see this conjunction of these two wonderful planets. Okay, that's my bit, Les.
Excellent, excellent. Thanks very much, Dave, and thanks especially for giving us an insight into what's going to be coming up over the next few weeks and up to December. So certainly some great objects to look out for. And I think Jupiter, Saturn, Venus, Mars, and even Mercury, these are all visible with the naked eye. Obviously, with Mercury, it's more of a challenge. And you need to be a little bit careful as well when it's close to the sun, or the sun's coming above the horizon. But these are all visible with the naked eye, and in fact, they were the first planets to be noticed by by the ancients, by our ancestors, sort of millennia ago. So get out and be looking up. And I think it's also worth saying that as our focus is on Mars, will be sort of fading in terms of what we call its angular size as it moves further away, but also its path through the night sky is sort of shifting more to the east on a day-by-day basis, just how its path or its orbit around the sun moves. So you may notice over time seeing sort of Mars's path almost moving eastwards. Great. Okay, I think it's time to actually move to our next location, which is down to over to the west to Bristol, Bristol Astronomical Society, where I think Dave, you're up first, and then be handing over to your colleague Ryan in a little while. So over to you, David.
Thank you very much, Les. Well, first of all, I'd just like to extend a warm welcome from the Bristol Astronomical Society. I'm located at our observatory a few miles west of Bristol, and it's really quite exciting to join the National Astronomy Week. I'll just start my presentation. So I hope you can see that. Yes, so yeah, welcome to our society. We operate a 12-inch Schmidt Cassegrain telescope, and we use it for public outreach such as National Astronomy Week and for general use by our membership. And this is it. I've got in the camera at the moment. I'd just like to say a few words about our society. It was set up by some fire watchers during the First World War. I guess I can only imagine blackouts in a prominent position in the city, looking out up at the sky for aircraft, and they must have wondered about the sky. So they started the first meeting of the society on the 8th of December 1942. And here we are, 78 years on. I'm pleased to say we've got a strong membership of over 100. Meetings are on Fridays. And of course, like everybody, we've been doing Zoom meetings recently due to the virus. But basically, we welcome anybody interested in the night sky. So it's great to be part of National Astronomy Week. And later, as you mentioned, let's be passing over to my colleague a bit further south, Ryan Parley, who's also going to give a little talk on cameras, etc. I thought I'd better mention, I said a 12-inch telescope. Well, what does that mean? Just in case there's any thoughts on that. But essentially, the 12 inches refers to the diameter of the primary mirror. And this cross section here shows a typical Cassegrain telescope like this one, where the light enters here, goes through a thing called a corrector plate, which on this picture just looks like a plain sheet of glass, but it isn't. It's carefully figured. Hits the primary mirror, that focuses it into a funnel, to a cone, comes down and hits the secondary mirror, and then back out through the primary mirror through the hole in the primary mirror. And at the back, you can attach various devices. So we've seen cameras today from the Gapus, which looked really interesting. So the main purpose of the telescope is just to collect light, so you can see fainter objects more brightly, and also you can see more detail. Those are the two main real reasons why a large mirror is beneficial as far as a telescope is concerned.
Dave, are there any downsides to such a large telescope? What would be the disadvantages?
Well, I guess the field of view is smaller for a start, normally. So if you want a nice wide field view, then I think people use astrographs with much shorter focal length. But again, a large size but shorter focal length is good for that. There's contrast as well. Sometimes it's better to see an image smaller because if it's very faint, it's very hard to pick up. And of course, a smaller telescope is not only more cost effective, but usually more maneuverable. So if you're talking about transportation and going out into the countryside to a dark sky, a small telescope is very useful in that case.
But for planetary, which is our topic, you need that big aperture, that long focal length for the magnification and the details.
Yeah, I would say so, certainly, yeah. Just a few basic stats about Mars. It's about half the size of the Earth. The Martian day is about the same as the Earth. It's 1.5 times further away from the Sun, and of course it has 2 small moons. We have 1 very large moon. But 2 stats I want to just quickly pick up on is the Martian year is almost 2 Earth years, which has been mentioned, and the orbit of Mars is noticeably elliptical. And this diagram shows Earth as the green almost circular orbit and Mars as the orange elliptical orbit. And on October 6th, just a few weeks ago, we were at the closest to Mars, and that was the opposition this year. Now, this diagram shows previous oppositions, and as you can see, the size of Mars isn't always the same at opposition. It depends where the opposition occurs on the orbit of Mars. So this is why it's an excellent time for viewing Mars at the moment. We get oppositions every 2 years because if you imagine the Earth and Mars here in October, Earth in a year will come back round to where it is now. But Mars will only got halfway around its orbit because it takes about 2 years to go around. So the Earth goes round another year, and Mars then has got back to where Earth is roughly. I say roughly because Mars takes a little bit less than 2 years. So Mars has gone a little way along its orbit, and Earth has to go a little bit further to catch up. So the next opposition would be around about here. So that's why we get oppositions every 2 years. And this is just a quick plot for the next 20 years. This is the time scale along the bottom axis, and on the vertical axis is the size of Mars. And we've just gone past the maximum size, so we're about here. And as you can see, about every 2 years, Mars drops and then rises, and we get an opposition, drops, rises, we get an opposition, and it gets smaller and smaller from now on until about 2029, and then it picks up, and in 2035 we're back to the size we are today. So we've got a few years to wait to get as good as a view as we have at the moment. Now, of course, we were hoping to see Mars tonight, but we can't. It's just too cloudy here in Bristol. So what I'm going to do is pop over to the 6th of November, and I took a small a short video through our telescope using a fairly simple camera, and I'll just show it to you. And this is, as we've seen before, Mars wobbling around in the turbulence of the atmosphere in Bristol. But you can see, I think, that little black finger there, that's Syrtis Major, which has already been mentioned, and you can compare it with the actual image, and you can see the match between the video and the image. I haven't processed them further, but I've been inspired by Akapos and what he's done, and I think I'm going to go away and take this video and see what I can get out of it.
Yeah, I think that would be great. I mean, it looks like you've got some good data there in that file to work from, Dave.
Yeah, I hope so then. And just to finish off, I mentioned the moons of Mars. Two tiny moons, Phobos and Deimos. Phobos is 22 kilometers across, and it goes around in 9.5 hours around Mars. So you could be on Mars and see the moon come round twice in a day, which would be quite interesting. And Deimos is further out, and that takes approximately 30 hours to orbit Mars. And I've just got a short little animation here which shows Phobos and Deimos going around Mars, Phobos being the inner moon and Deimos being the outer moon. So the question is, can you observe them? And Pete Lawrence put down a challenge in the Sky at Night article before this opposition, and so I had a go just to see what I could do with the camera, and this was on the 15th of October, and I think people say no, I can't see them, but there are two kind of spots, one there and one there. You may not be able to see it on your computer screen, but it's clearer to me. At least I would say that, of course. And the other thing is just a blemish, a dust spot on the lens. Now, cloud came across. It was a cloudy night. A thick area of cloud came across, and at this point, it acted like a filter, and you could actually see Mars out of the glare. So that was reducing exposure without actually touching the camera. It's just nature doing it with the cloud. And
interesting, you've just mentioned the word filter. We haven't sort of talked about that before, but we have had a question that came in. It was obviously talking about one of the previous images. But do you use filters? Would different color filters help in bringing out more details or contrast?
I tried a red, green, and blue filter separately, and I've used a red filter to try and improve the contrast in the image, and that's what I've used, Les, on that. So yeah, you just got to try it and see. I think it's generally accepted that red is the better filter to use when doing a visual observation. And finally, that's an image that I've taken from just one frame from the film, where I've tried to stretch it, and you can see a little blob there, and maybe just a blob there. But anyway, that may or may have not been the moons. I think they were, because I can match them up with the animation. But it would need several more hours of observation just to check their motion to be absolutely sure they were the moons. But I believe they were. Okay, so that's me finished, and I'd like to hand over to Ryan.
Well, thanks very much, Dave. But just before we head over to Ryan, I've had a message from Agapius to say he's got Uranus in view, but it's starting to get a bit cloudy over in Cyprus. Now, goodness knows where that weather came from, Agapius, but perhaps we could just do a very quick head over back over to Nicosia and just see if we can get a quick live look at Uranus?
Yeah, absolutely. So we do have some clouds here, but I think I can show you what I've done. So here we have the distant planet Uranus. I don't know how well you can see that. Is that coming through?
Yeah, marvelous.
Okay, so there's the tiny, well, seemingly tiny planet Uranus, a completely different view to what we got before with Mars. I mean, obviously Mars is that much closer to the Earth. Uranus is quite distant, and it's always a challenging object to observe. But I find it can be very rewarding as well. One would typically use larger, preferably larger telescopes to observe a planet such as Uranus. In this case, I'm using a 14-inch, so there's plenty of light gathering power there, but one can also use smaller telescopes such as an 8 or 10-inch and can have a very rewarding view of Uranus. Its color is very distinct in the eyepiece. And using the same method as before with stacking many frames, we can pull out some nice details. Uranus is showing a bright polar hood, and that comes across quite obviously, although on a very, very tiny angular size. I've been taking some data on Uranus in between the clouds, and I'm going to try and process them and maybe come back and show just before we hand off.
Excellent, excellent. Great. Thanks very much for that quick update. I think what we'll do is we'll head back to Bristol now, and over to you, Ryan, if you're ready.
Hello, good evening. Can you hear me all right?
Yeah, loud and clear.
Fantastic. So, yeah, down here in, well, just on the edge of the Somerset levels, as for most of the UK, it's pretty cloudy. So we're on plan B, and I was just going to do a little bit of a talk about some of our kit that we use for kind of real-time astro video work, really. So yeah, yeah, let's get on with it. So yeah, I'm talking about real-time video astronomy. I'd say, yeah, it's very nice to be here with all you guys, and yeah, much appreciate being able to come and help you out. So yeah, I'd just like to say a little bit about what it is I'm going to be doing. So what is real-time video astronomy? So we're picking up the most sensitive video cameras we can get our hands on. Some of them are consumer level, some of them are aimed slightly above the normal reach of a consumer, but you know, they're very useful. The cameras that we use, they're way more sensitive than the human eye now. We can capture almost daylight-like images in almost complete darkness. There'll be some fantastic natural history documentaries coming out fairly soon using similar equipment to the sort of thing that we like to use. So yeah, technology has moved on no end, and it's really going to, I think it's really going to have a big place in astronomy, where it will allow people to see like telescopic views, but quite impressive telescopic views instantaneously on a screen. So that kind of makes it ideal for outreach events where you may have, you know, a number of people all sort of buzzing around an observatory site, and you have a little screen there and everyone can see it. There's no, you know, little kids who can't reach the eyepiece, or, you know, potentially it certainly helps out with accessibility for, you know, people, disabled people, wheelchair, or even people with certain visual impairments, you'd be able to potentially view it on a screen, which is great. Another thing where it works out great is we can stream it over the internet, so it's great for this COVID-19 environment we're living in at the moment, and works good for these remote outreach events like this National Astronomy Week we're on now. So you need the kit you need isn't particularly specialized. For example, you need a decent camera that's got a good light sensitivity or good sensitivity. A great starter camera is the Sony A7S series. I'm using an A7S Mark I for what I do, and you can pick one of those up used on eBay for, I don't know, 800 quid to £1,000, possibly less. I haven't looked for a little while. And the latest one in the range, I think, retails at about £3,000. So they're not horrendously expensive bits of kit. We also use a Canon ME20, which is a rather specialist camera from Canon. It's got an ISO of about 4 million ISO. So yeah, it can see really dark at 4 million ISO. Your image isn't much good. It's more for like a surveillance purpose and like military use, for example, so they could just detect someone in the dark. But it works great. Some of the modern CMOS cameras that you can get now, they're just starting to get the sort of speeds that we need to be able to actually keep up with the video stream. Yeah, some of those now I think might start coming into being useful. One bonus of those is you can hook it straight up to your PC with USB. No fancy cables or adapters or anything. Malincam offer a good range. They are these little things. They look like modified CCTV cameras, and for all intents and purposes they are. But Rock Malin works some magic with the sensors on these things, and yeah, makes them, they're really impressive. We've used them for stargazing live in the past, and yeah, they produce some pretty fantastic footage, certainly for planetary sort of subjects. You've got high definition cameras for planetary use there. Your telescopes and your optics, well, the general rule is the faster the better. Certainly for deep sky, you want to be f4, f3 if you can do it with a telescope. And if you're using lenses, you've got to be faster than f2.8, just to get the light. And you can get some relatively cheap lenses on the market now. The lens I'm shooting through here is an f1.5, and that cost me about 120 quid. So yeah, you can get them relatively cheap. And then you will also need some kit to record and view your footage. So you can use a capture device on your PC or your Mac. If you've got an onboard card reader like your traditional cameras, you can use that. Or an external video recorder, a little box with a screen that you can send the signal through to record it, save it to a medium, and off you go. Hang on, I'm just seeing something in the chat. Excuse me.
Yeah,
okay.
it's Ryan. It was a question from Sophia, age 10. She's got a Celestron reflector with a 300mm focal length, 3-inch aperture, and she was asking, in addition to the eyepieces, she's got a 20 20 mil and a 10 mil. Would there be any other accessories that you could recommend that she might be able to use to help get the best out of that equipment for planetary?
Yes, 300 mil f10 is quite a limited telescope, but for what you can do with the aperture, certainly you're going to struggle to get some bright images, but you can certainly have a play around. Celestron used to offer, although I haven't looked for a little while, they used to offer a kind of modified webcam that will have the eyepiece adapter. It will plug straight into your telescope, and you can plug that into your laptop and see how you go with it.
Excellent, great.
Okay. Right, I better press on. Actually, I'll just
I've got a sort of another couple of minutes to go, Ryan.
So I'll just basically like to just go through now and just show you a few bits of footage. Some of them aren't totally amazing, but they're just give you an idea of what you can see, and in real time. So you've got to remember here, there's no stacking going on. There's no long exposures. This is a live video feed. Every frame's coming through at 25, 50 frames per second. So start with, we're going to have a bit of a look at Andromeda. So Andromeda Galaxy is our closest neighbor. It's about 2.5 million light years away from us. Most distant thing you can see with your naked eye. And in around 4.5 billion years it might collide with the Milky Way, and I'd love to be around to see that, but I don't think I'm going to last long enough. It's relatively easy to find. If you can see on screen here, we have the square of Pegasus, and then you follow the arms out of Andromeda. If you count the pairs here, the first pair, the second pair, and then you go over about the same distance as the first pair, as this pair here, out to here, you'll find it. Using binoculars, you're guaranteed to spot it. It's very easy to find. And okay, I'll now go on to a little clip of that. So here we have an image. This is taken with the infrared filter turned off. So it's a bit like a lot of astrophotographers like to remove the IR blocking filter from their camera. The ME20 can do that automatically, electronically, internally itself. So there's no messing around with that. And then the Pleiades. So if we go on to the Pleiades is an incredible object. It's certainly responsible for getting a few astronomers into looking at the night sky, including myself. It was the first thing I noticed about the night sky. Again, very easy to find. If you can find the V shape of Taurus, the Hyades, with the bright orange star Aldebaran there, you will see a nice little cluster of stars above it. There's quite a few of them. You can typically see around 7 with the naked eye. And we've got a nice little clip of it here, taken earlier in the spring, and it was. Could
you show that now, Ryan?
Yeah, so I'm just going to transfer that one over to you now. So here we have Venus glowing quite brightly with the Pleiades in the background. And
yes, remember that. Yeah.
Another clip here. This is just showing the Pleiades. These are this was taken with I believe 135mm lens. So you can get in closer than that. We're just kind of doing what we can with the footage that we had available. We'd like to have given you some closer shots.
Right, Ryan, we're going to have to just draw it to a close from your end because we're sort of less than a minute away.
Okay.
But thanks very much for showing us the power of sort of live streaming, you know, in real time, if you like, of Pleiades and Andromeda. Really, really impressive. I'm just going to just finish off with a very quick view of what you might see if you were on Mars right this moment, and looking back towards the sun, and the possibility of seeing the Earth and Venus and Mercury in the distance. So that is what it would look like from the Spirit lander. And if we've got just a few seconds left, Agapius, have you still got Uranus there, just to leave us on a high of a live stream, and then we can
Absolutely, yes.
we can just sort of finish off with some lovely clear skies over Cyprus, and finish off on a high, as opposed to in the wet weather that's here over the UK.
No, the clouds are almost completely gone, and we have Uranus on the screen there. It's looking really nice, actually. And I was able to do a quick capture, and I can pull it up side by side to Mars, so that we can compare, if you like, the apparent sizes through the telescope. I don't know if you can see that very well. So there's the view of Mars on the left side of the screen that we got before, and on the right we have Uranus. You can see how Uranus is, you know, tiny compared to Mars, and almost no other detail is visible other than its striking color. Of course, this was done with no specialized filters, so it wasn't possible to capture any detail on Uranus. But still, a nice view, in my opinion.
I was just saying that that's something you've just captured in real time. So really using what Ryan was telling us a moment ago about real time astronomy, and actually getting the data and being able to share it back with everybody right now.
Yes, and it's one of the great joys of doing this is the ability to share and show others what you're seeing. And it's quite different to somebody who's doing just visual astronomy, and you come back from a stargazing session and you describe what you see. But in this case, you can come back with actual images and show what you can see through a telescope. It's quite effective in getting people interested and inspired.
So excellent. Well, look, perhaps we could just bring everybody back onto the screen, because I just want to say thank you to our intrepid practical astronomers for this evening's show. I mean, talk about a hybrid between Plan A and Plan B. I think we've managed to pull that one off. Thank you very much, Agapius in Cyprus. Where's everybody else? Have we still got Dave Eagle in the Midlands, and Dave Bennett and Ryan over in Bristol? Can they join us?
Yeah, I'm still here.
Hey, Ryan.
Yeah.
Excellent, great. Well, look, we've had some fantastic images, some in true Blue Peter style, prepared in advance. So thanks very much for pulling those together. We've had some great advice on some of the equipment we need from Ryan, and then some of the techniques from Dave. We've learned about the observatory and Bristol Astronomical Society. I'd just like to say from my side, I'm here in Havering Astronomical Society. So as and when we can all start to sort of see each other in person, you know, make sure you make your way to your local astronomical society and say hello to everybody, find out more about how you can see what some of the guys here have been doing tonight. So I think perhaps we can all sort of wave a goodbye and hand back to Lucinda.
Brilliant. Thanks, Les.
And tell us about tomorrow.
Thank you so much, guys, for everything. And let's see, what do we have on tomorrow? We've got, well,
Mars on Earth.
The Mars on Earth at 11 a.m. with an activity with Joe Fox and also we're going to be looking, having a an activity from Ireland as well, ILOFAR. And then tomorrow evening, we're going to be talking about doing a panel discussion about a comparison of Mars and Earth. So lots to look forward to tomorrow. Again, goodbye. Thank you, everybody, and have a great night. Thanks for being with us.